Okay, so we're doing number 7 on the January 2020 exam. Looks like we got a sine, cosine, tangent problem mixed in with a similar triangle problem. All right, so we know that the two triangles are similar. Are we in the habit yet of saying, hey, when two triangles are similar, corresponding angles are congruent? So if I'm looking for angle F and you look at that triangle, I know nothing about that triangle DEF. So how in the world do you expect me to find F? And the sides aren't congruent either. So it's not like I can throw 17 on DF and BC I can't, there's 15 and I can't throw that on FE. It's not going to happen. Corresponding sides are proportional, not congruent. Abbott, but what is angle F congruent to?
Angle F is congruent to
angle C. So if you guys find angle C, you have angle F because the triangles are similar. Everyone see that? All right, now, once I know that fact, hopefully this becomes a little bit easier because now I'm using sine, cosine, tangent. So now I know angle F congruent to angle C. So if I could find angle C, I'd be all right. Now this is sine, cosine, tangent. I'm going to start calling on everyone. If I'm going to find angle C, what's the 15? Opposite adjacent hypotenuse, and what's the 17? I want both at this point. I want both. Tell me what both are. Here we go. 9. What's 15? Adjacent. How about the 17? Hypotenuse. Again, I won't have that board up there, so you got to know how to spell SOHCAHTOA if you're going to use it. All right, that board won't be down in Gym B. So what do I use if I have the adjacent and the hypotenuse side? Which one of the three? 13? Cosine. So I'm going to go cosine, and you can put whatever variable you want here. X, I'm going to put C because that's the angle we're finding, equals adjacent over hypotenuse. Have we gotten enough practice in this yet that we don't cross multiply? Because I'm finding an angle. If I was finding a side, I'd cross multiply. But when I find an angle, we know we go right to the calculator and do the inverse. The inverse when I find an angle using sine, cosine, tangent. 15 over 17. And this is why you need to change your calculator into degree mode. If you left it in radians, it's not going to be, and I don't even know. That answer might be up there, to be honest. That's how ridiculous these test makers are. If you left your, hey, watch, we'll get them because they didn't listen and put their calculator in radian mode. We'll put that answer up there too. And then I'm not too sure what the answer is, but everyone should be rounding to the nearest degree and finding something in the multiple choice. We good, Nick? Rachel, go ahead. Let's keep asking anything here, guys. At this point right now. Number 6, right? Yes? Okay. Whoo, yeah. This one's brutal. Brutal. And it's only number 6. The toughest part about this question is understanding what topic it is. You know, what topic would this fall under? Because everyone sees, at first, they give you it's a trapezoid, so everyone thinks this is a quadrilateral problem, but it's not. It has nothing to do with the trapezoid. The only thing the trapezoid gives us is AB is parallel to CD, and they gave us that for a reason. Let me throw some stuff up here. AE is 5.2. This whole side diagonal is 11.7. CD, the base, is 10.5. And the top base is what we're looking for, right? What's AB? Yep. All right, guys, this is a tough one. Let's start here. They told you those two bases were parallel since it's a trapezoid. Now start thinking parallel lines, and you know special angles are formed, right? Anybody can tell me a pair of angles that have to be congruent because those lines are parallel. And then I'll get you to where you need to be. Give me a pair of angles that are formed by parallel lines that you know are congruent in this diagram for me. Give me a pair. Come on, give me a pair formed by parallel lines, and you know they're congruent because it's these types of angles. Anything you see up here. 2, Nate, anything you see. Angles formed by parallel lines. If not, I'll just move on. Okay, make sure you write it down. 13, see anything, Charlie? Good, name a pair up there.
Angle BAC, angle DCA.
Okay, BACN, DCA. Alternate interior angles are congruent if I have parallel lines. Great job. Okay, now I'm looking for another pair because that's not the only pair up there. Name another pair. 5. Okay, so you got the. All right, you got me there. I thought you were going to go to the other alternate interior. But yeah, I got verts up here, right? Everyone see the vertical angles? Where the heck am I going with this? Because I'm trying to find a side length, and I'm talking about angles. Where am I going? Look at this triangle that contains 2 of those angles, and the triangle right below it. If they contain 2 pairs of congruent angles, what do I know about those triangles I just highlighted up here in pink and brown? If they contain 2 pairs of congruent angles, 2 pairs of congruent angles, what do I know about those triangles? 9? Similar. They're similar. That's what this problem is. It's a similar triangles proof. And if they're similar, that means their corresponding sides are in proportion. Now this is a very easy problem because the sides aren't that tough to match up, I think. Give me a side in one of the triangles so I can match it up. 6, give me a side in one of the triangles. 10.5, that's in the brown one. And that matches up with what side in the pink one? Keep going, Nate. X. Yep. Here's the only little piece of work you need to do. Give me another side in the brown triangle so I can put it with the 10.5. You're going to have to do a little math, I know. Give me another side that you know in the brown triangle other than 10.5. Nate, 2. And I'm looking for EC. How can I find EC? The diagonal was 11.7. AE was 5.2.
Oh, just subtract.
Okay, go ahead.
Uh, 6.5.
Okay, so there's 6.5, and it matches up with the 5.2 in the pink triangle. And there's the proportion I needed. So it wasn't bad at all once I knew they were similar, but I had to get to that point. Had nothing to do with the trapezoid. Use all your facts. They told you they were parallel for a reason. Alternate interior angles are congruent. That gets you angle. Rachel, we good? Others from the multiple choice section, or I'm moving on. Okay, this is my last day of going over problems. Tomorrow is all 40 minutes of you guys doing like a review session together. All right, this is it for me up here. Okay, go to parts 2 and 4, and I think we're starting with 26. These are all ones we should be able to do at this point. Probably not, I know, but these are all ones we've at least discussed. So go to 26, read through it, and then I'll ask you what your thoughts are. Whew. All right, ready? What are we thinking for this one? All right, come on. I don't know what else to tell you here at this point. We got a week away here. Nate, go ahead, talk to me. Anything at all? We got a week here. We got a week. What type of triangle is it?
Right triangle.
Right triangle. There's a lot of things I can use with right triangle. I have a degree measure. I have 2 sides. Anything coming to mind?
You could do sine, right?
Why?
38 is
What's the 24.5?
Opposite.
And what's the x?
Hypotenuse.
All right, there you go. And notice what section is this under? This is a 2-pointer, right? Shouldn't be too much work. Sine 38 equals 24.5 over x. Since I'm finding a side, cross multiply. Since I'm finding a side, cross multiply. You got your Chromebook on you?
Yes.
Okay, print this out, go get it. All right, because I can't have you just watching this. If you're going to be here, we're going to do some work. Cross multiply. And let me know what you get. What are we looking? Nearest inch now? Nearest inch. 1. Anna, what do we got? Nearest inch.
40 inches.
40 inches. Can I get a confirmation there? We're good? Okay. Okay, 40 inches. Questions? All right, let's move. Let's move. I'm going to 27 next. January 2020. What type of problem is this? 43 pounds per cubic foot. And you're looking for the weight of it. It's a density problem, right? And hopefully you guys aren't going nuts here. Better. Oh, are we taking our time here? Anybody see the issue before I even start? You can't find volume right now. Nobody should be finding volume unless you made a change. Nobody should be finding volume. Read the density again. 43 pounds per cubic foot. Read your dimensions. 8 feet, 3 feet, and then the problem. 1 inch. All right, so we can't just be doing 8 times 3 times 1. Before you find the volume, you need to change all the units to the density units. So this 1 inch needs to be changed into feet. If you're concerned, do I divide or multiply by 12? Set up a proportion. 12 inches equals 1 foot. I have 1 inch. How many feet would that be? And cross multiply. I don't know what that decimal turns out to be. I'm just going to leave it as a 12th. 1/12 of a foot. Now you can go ahead and find volume. Make sure all the units are the same before you find the volume. Now we can go 8 times 3 times a 12. So the volume, 2. My math's right. Right, 2 cubic feet. All right, now, yep, you told me it was density. Now we can determine the weight in pounds. So density was 43. Mass I'm trying to find. Volume was 2. £96 pounds. Nope. How about 86 pounds? A quick check too. Make sure the density was pounds, so whatever I got for my mass would be pounds. If I had to change it to tons at the end, in tons, I'd have to convert at the end again. All right, watch out for that. Watch out for the density problems. All right, let's go. What's up next here? 28, right in a row, 28. Circle fact. Let's see if we remember. We've gone over this one. Might have been on your good old multiple choice quiz from last week. Do we remember this circle fact? CA is 12.5. CB, 4.5. What's the length of DA? And we have a secant and a tangent. Anybody remember the rule? rule? Spence, did you remember it?
Whole times external.
Equals
The whole.
whole times external. Okay, that anytime you're dealing with secants or tangent lengths, whole times external equals whole times external. All right, so since it's a tangent, the whole and the external, same thing. All right, tangent, the whole and the external are both the same. Equal to whole thing on the secant, 12.5, but how do you find the external part here? 3. Spence, how do I find the external part? Because I don't want to use 4.5.
Can you subtract 12.5 of 4.5?
And what's that, 8? Okay, make sure you do the external part. Don't use 4.5 in your calculations. What's that, 100? No, is it? 100? If there's no rounding directions, none are needed. Remember that. If you don't see to the nearest whatever, and you have a decimal answer you think you need to round, it's for a reason. Something went wrong. Okay, anything? And then let's keep going. Oh, we haven't talked about this at all. 30. This is the first time we've discussed this one. All right, so let's slow it down a little bit. All right, let's start here. These are medians. In the directions it said, all of them are medians. And they all intersect at C. C had a name where all the medians intersect. It was called the centroid. All right, the centroid. And the special fact about the centroid was it broke any median. Any of these 3 medians now are broken up into a ratio of 2 to 1. All right, so this part, for instance, YC is double the length of CF. All right, so for instance, YC equals 2 times the length of CF. And I could do that for all the medians now. Okay, that's called a centroid. One piece is double the other. So anybody want to find XC now that we just went over that fact and theorem? Anybody know the length of XC now that we just went over that? It's breaking, C is breaking XE up into a ratio of 2 to 1. We already know that piece is 5. Other piece, XC, 8, 10. So XC is 10 because I know that's a centroid and it goes to a ratio of 2 to 1. All right, can we talk about YF being 21? If YF is 21, what's each piece if I know it's in a ratio of 2 to 1 now? Right? One piece is double the other. So if the whole thing equals 21, it can't be 20 and 1. That's not double the other. All right, what must be YC and CF then? 2 to 1, and the whole thing is 21. 2 to 1. Abbott?
7.
Okay. FC is 7. CY is 14. If you're interested on how to get that a little bit more than just guess and check, 2x plus 1x, right? 2 to 1. 2 to 1, I put x's with them, equals the whole thing 21. And then I have one more side, xf. And everyone agrees that's not part of the median. So the centroid rule is out. What's the definition of a median, though? Starts at a vertice and goes to the opposite sides. Midpoint. So guess what f is? A midpoint. meaning FZ is congruent to FX, definition of a midpoint. Medians go to midpoints. So take half of 15, and we get FX to be 7.5. And now you guys can find the perimeter. Tricky one. Had to know definition of a median and centroid on that one. So your perimeter, 7.5 plus 7 plus 10. Okay. I figure we'll end our review, in-class review, the same way we started. Go ahead, go to 31. Here's our basic parallel perpendicular line going through a point question. You cannot find the slope of the way this was written. We need to get it into y equals form. Go ahead, somebody help me here. What's the first step in getting it into y equals form? 11? Okay, that's either one. Could have done either one. Just got to get y alone eventually. Negative 4y equals negative 5x plus 10. Next step, if we're doing it this way, 5. Divide by negative 4. All right, take a peek here. Everyone see a negative divided by a negative? So it's going to be 5/4 x. And it doesn't, the y-intercept here, it has no effect on the problem. So even if you get this one wrong, that it's negative 10/4, okay, it doesn't matter. I'm concerned about the slope. All right, the slope here, 5/4. So what's going to be the slope of your, we're doing perpendicular, right? What's going to be the slope of your perpendicular line then? Come on. 10? Flip it and change the sign. You got, flipping it is just not good enough. You got to change the sign. So negative 4/5. Last thing we need to find, what's the y-intercept? And we always do that using y equals mx plus b and solve for b. So I need help from someone. Plug in for y, m, and x for me. What goes in for y, m, and x so we can solve for b? All right, let's do this. 1, Anna, what's going to go in for y? 12, the y coordinate it goes through. How about the m, Anna? 4/5? Negative 4/5, yep, the perpendicular negative reciprocal we just found. And then finally, Anna, how about x? 5. And then we solve for b. $16, hopefully, for your y-intercept. And then put the two together. Anything there? What's up, Spence? What did
And you 16?
let's see, make sure I didn't do it. I multiplied negative 4/5 and 5 and got negative 4.
Yeah.
Right? And then I added the 4 over. Right? Because I got to get b by itself, so I added the 4 over. All right, go back to the start of part 2. Let's start doing some part 2, 3s, and 4s. Call me over if there's issues. If there's a construction, get out your Chromebook and open up the construction videos to find which one you need. If you need a compass or a straight edge for any of those, I'll put them down on the group, this group in the back here. And then tomorrow you're going to come in and